We just talked about how equilateral triangles, anytime you drop an altitude in an equilateral triangle, it will always create a 30, 60, 90, or two 30, 60, 90 triangles. Now, squares are special as well. If you draw a diagonal in a square, it's going to bisect the opposite corners of a square, creating two 45, 45, 90 triangles. So if you don't remember this, all four corners in a square are right angles. If I bisect the corners, it's going to cut them perfectly in half. So that creates 45, 45, 90 triangles. And because of our 45, 45, 90 rules, that means we have congruent sides with S, S, and S root 2 as the hypotenuse. So let's take a look at an example of this. You will be expected to sketch these out and solve. I have the perimeter of a square is 48 meters. So first off, I have a square. It has a perimeter of 48 meters. So if it has a perimeter of 48 meters, that means all four sides add up to equal 48 meters. So first, let's go ahead and draw our line that's going to bisect. So I have right angles here, and then my 45-degree angles, 45, 45. Now, we know about squares that all four sides are congruent. So we've got congruent, 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 congruent. And based off of our 45, 45, 90 chart, we have S, S, S root 2. So each one of these sides is represented by an S. If I take 4S, which would represent our perimeter, equals 48, that will tell me what S is. So I divide by 4. S is going to be equal to 12. Then I need to find S root 2, which is the diagonal. So I take that 12, I plug it in, and 12 root 2 is our diagonal in meters.